Hello, class. The topic of today's lesson is comparing two proportions. We are officially starting chapter 10 in our textbook, and our first objective and our only objective for today is going to be to determine whether the conditions are met for doing inference about a difference between two proportions. Remember that included in those inference methods are confidence interval constructions and hypothesis tests. Now, in chapter 9, we did the same thing, except we did our inference on just one proportion or one mean. So chapter 10 covers comparing two proportions and comparing two means. Tomorrow we will go through the whole construction and interpretation of the interval, but for today we are going to look at the conditions. Now, before we begin, I wanted to talk to you about an application of this confidence interval for the difference between two proportions. Now, there was a study called the Prove It study that was an experiment that involved 4,000 people with heart disease. Now, these 4,000 people were volunteers because you can't force anyone to be in an experiment, and not everybody has heart disease. So these individuals who volunteered were randomly assigned to two treatment groups. One of the groups was the Lipitor group, and the other group was the Pravachol group. So these are two different types of medications that were given to those two groups. Now, at the end of the study, researchers compared the proportion of subjects in each group who had either died, had a heart attack, or suffered other serious consequences within those 2 years. So they wanted to look at both of those proportions and wanted to see which group had a higher incidence of heart attack and other serious consequences versus the other, to see if there was one medication that was more effective than the other. For those using Pravachol, the proportion was 0.263. Those using Lipitor was 0.224. So as you can see, roughly about a 4% difference there in those proportions. Now, could this difference have occurred purely by the chance involved in the random assignment? Or was it due to the medication? Did the Lipitor cause the incidence of heart attack, stroke, etc.? Did it cause that proportion to be lower? And this is a question for comparing two proportions. So sure, a lot of this is going on nowadays, especially with all these new clinical trials for new medication to see if we can get a vaccine for COVID-19. All right, so comparisons between two proportions are more common than questions about isolated proportions. And that's what we did in chapter 9. These are much more interesting. And this allows us to compare two groups. We can compare a treatment versus a placebo, or whether results maybe for a test are better than previous year's results. So in that Prove It experiment, the goal of the inference was to determine whether the treatments caused the observed difference in the proportion of the subjects who experience serious consequences. All right, so these are our conditions, and you're going to notice some similarities to what we talked about last chapter. We still have a random condition, so your data should come from two independent random samples, that's if you're sampling, or from two groups in a randomized experiment. The 10% condition applies when you are sampling. So if you are conducting a randomized experiment, you can actually ignore the 10% condition. But when you are sampling without replacement, you want to make sure that your sample size is less than 10% of that first group. And then you want to make sure your sample size of your second group is less than 10% of the population size of the second group. We still have a large counts condition, but you've got to do this for your two separate independent random samples. So here it's n sub 1 times p hat sub 1, and also n sub 1 times 1 minus p hat sub 1. So everything you learned in chapter 9, we're extending it now to two different proportions. All right, and these still have to be at least 10, greater than or equal to 10. All right, so in this problem here, I want you to go ahead and pause the slide and read through all the information and the context there, and we will check the conditions for calculating a confidence interval for P sub U, which P sub U being the true proportion of all U.S. adults who think brand names are important when buying clothes, minus P sub G, which is the true proportion of all German adults who think brand names are important when buying clothes. So go ahead, pause the slide, read through the context, and we will check those conditions. Okay, so let's go ahead and highlight some key information here that we are going to need. So for one, we've got the fact that these are independent random samples of adults from the US and Germany. That's a very important statement that needs to be made. We've got a sample size here of US adults of 2,309, and we've got a p-hat for US adults of 26%. And we have a p-hat for the German adults, and we've also got a sample size for German adults. All right, so on the next slide, we're going to go ahead and break this information down and check our conditions. All right, so the random condition should be written out in a complete sentence. So you have independent random samples of 2,309 US adults and 1,508 German adults. Now, since we are sampling without replacement, we've got to check the 10% condition. And as you know, 2,309 US adults is definitely less than 2% of all US adults. There are probably, 100 to 200 million US adults in the country. Way less than 10%. Totally fine on that. And likewise, there are a lot of adults in Germany, millions. 1,058 is definitely less than 10% of all German adults. So that part of the condition works out. All right, now the large counts condition. All right, so notice the use of subscripts here specific to the proportion. So for the US part, we are going to take n sub u. So 2,309 is our sample size for the US adults. And our 26% is our p-hat for US adults. So 2,309 times 0.26 is roughly about 600. Now, we have to multiply by 1 minus p sub u, so that gives us 0.74. 1 minus 0.26 is 0.74. And when we multiply those two numbers, we get about 1,709. So we've got to do the same thing for the German adults. So if you look here, the 22%, that is our p-hat sub g. And our 1,058 is our n sub g. So we're just going to take all those values, plug them in, multiply them, and notice you're going to get four different values there. And all of these are greater than or equal to 10. All of these values have to be greater than or equal to 10. So we satisfy the condition. All right, I want you guys to go ahead and pause the video, and I want you to try to check the conditions for this problem here. Okay, so this problem was about brand preference between the genders at a large high school. So we have P sub F representing the true proportion of all females at the school who prefer Nike over Adidas, and P sub M is the true proportion of all males at the school who prefer Nike over Adidas. And we have some values for N sub F and N sub M, and we also have the proportion of P hat sub F and P hat sub M. So notice the order here, P hat sub F minus P sub M. And let's go ahead and check the conditions for this. So the random condition, independent random samples of 40 females and 30 males from the school, that checks out. 40 is less than 10% of all females at the large school, and 30 is less than 10% of all males at the large school. We're assuming that's true. As we said in class, there's typically about 2,500 students at a large high school. And assuming, about half the student body is female and half is male, 1,250. These numbers are well less than 10%. Now, when we go and check the large counts, we run into an issue, however. the sample of 30 against the 1 minus p hat, there should be a p hat here, apologize, 30 times 1 minus p hat sub m gives you 6, and that does not satisfy the condition. Now, if you take n sub m of p hat sub m, you will satisfy the condition, because you will get 24, which is greater than or equal to 10. So although that part of the condition works out, the 1 minus p hat sub m condition does not work out. All right, so you don't have to check the other part of the large counts condition because you failed on this portion here. So you can go ahead and stop, and you are all done. All right, so that wraps it up for today. Tomorrow we will go ahead and construct and interpret a full confidence interval. But for now, I just want you guys to focus on checking to see if you can actually do one of these intervals in the first place. Have a great day, everyone.